All right, algebra. This week we're going to review exponential growth and decay and linear versus exponential before we get into a new unit on sequences. All right, I want to remind you that if you didn't, you should download the app Calculate 84 on your phone, unless you already have a graphing calculator. All right. When you do growth and decay, remember, everything starts at 100%. If the amount is increasing, you're going to add the percent to 100. And if the amount is decreasing, you're going to subtract from 100. So number one says a savings account grows by 3% per year. Right? When you put money in a savings account or you borrow money and there's interest, the amount is always going to go up. All right? So Sophia places $500 in the account at the beginning of the year. Write an equation to represent the amount of money in the savings account. All right? So this amount's going to go up. So we're going to add 3% to 100. Okay? Which is going to give us 103%. All right? This is our growth factor. But before we put this in our exponential equation, we have to convert the percent into decimal form, and we do that by moving two places to the left. So this is our base. This is our multiplier. So if you go back to an exponential function, y equals a times b to the x, this is your b. A is your y-intercept, which in this case is the amount of money you're going to start with. So our formula, y equals 500 times 1.03 to the x. All right, or they might use t for time. All right, so you could have also wrote a for the amount of money instead of y equals 500 times 1.03 to the t. All right, a lot of times you're going to see t for time. All right, they want to know how much money will Sophia have in her account after 5 years. So they're giving us the time. So all you're going to do is plug in 5. 500 times 1.03 to the fifth power. All right, 500 parentheses 1.03. Hit your exponent button, which is on the right here, to the fifth, and that's going to be $579.64. All right? Keep in mind, things that are going to grow are bank accounts, value of precious metals like gold, silver, platinum, diamonds, things like that, gems, those are going to increase. Values of homes, generally going to increase. All right, what's going to decrease is the value of any other product you'd buy, like a car or a computer, that sort of thing. So that's where number 2 comes in. Malik bought a new car for $24,000. The value of the car depreciates. All right, look at that word. Kind of looks like decreases at a rate of 12% each year. Write an exponential function to represent the value of the car after t years. All right, so you buy a car, the value is going to decrease. Remember, you always start with 100. This time it's going to decrease, so we're going to subtract. So our value of our car is going to be 88%. And when you plug it into the formula, you got to move the decimal place 2 places to the right. So that's 0.88. That's our B. All right? So our value is going to equal the original amount, 24,000, times our rate, 0.88 to the T. All right? Part 2. How much will the value of the car be after 2 years? All we're going to do is take our formula, plug in 2 for the time. Just like that. So you got 24,000, parentheses, 0.88. Hit your exponent button to the second. And it's going to come out to $18,585.60. All right? All right, let's take a look at a couple more examples. Okay, number 3, a rare coin appreciates. All right, that means it's going to increase in value. Depreciate would be decreasing in value at a rate of 5% a year. The initial value of the coin is $200. Write an equation to represent the value of the coin. All right? Again, we always start at 100%. It's going to increase, so we're going to add. It's going to come out to 105%. That's our multiplier. That's our rate. But we have to do that in decimal form. So we're going to move our place value 2 places to the left. So 1.05. All right? Our value, V, is going to equal the original amount, 200, times our rate, 1.05. And the time is your exponent. All right? So that's your equation. How much will it be worth after 10 years? All you're going to do is plug in 10 for the time. All right? 200 times 1.05 to the 10th. All right? Which comes out to 325.7789. And again, money is going to be to the nearest cent. So that's the second place value. That's a 7. The 8's going to go up. Going to make the 7 go up to an 8. $325.78. All right? All right, I'm going to do a couple more quick examples with you. All right, sometimes they give you the equation. And then you got to go backwards to figure out what the base means. So it says for the equation A equals $1,750 times 1.02 to the T is being used to calculate the amount of money in a savings account. What does 1.02 represent in the equation? All right, so what you do, this time you're going to go backwards. You're going to change the decimal to a percent. So instead of moving to the left, now we're going to move 2 places to the right. I have 102%. Then think about how much more or less is this than 100? Compared to 100, this is 2% more. So if it's 2% more than 100, that's growth, or 2% growth. Now, if they asked what does 1,750 represent, that's the original amount, or the initial amount, or the starting amount. All right? So the coefficient is the amount you start with, or your y-intercept. This is your rate. All right? All right. Number 5, similar question. John buys a new car for $18,000. Think about what's going to happen. The value is going to decrease. The value of the car, V of x, is modeled by the function V of x equals 18,000 times 0.92 to the x. All right? Again, 18,000 is the starting amount. That's the original value of the car, where x is the number of years since he made his investment. Since he bought the car. Which statement best describes the rate of change? All right? So you take your 0.92, all right, and you want to convert that to a percentage. It's going to be 92%. All right, remember, always think, where is this from 100? This is 8% less than 100. So that's an 8% decrease, or an 8% decay. All right? All right, try the rest of these questions. Check your work. Talk to you soon.